Welcome back to The Explainer. I am absolutely thrilled to have you here today because we're tackling one of the most critical and honestly surprisingly misunderstood decisions that builders are facing right now in 2026. We're talking about the open weight model landscape. Look, if you're building AI apps, you've probably already realized that the old naive approach of just grabbing the absolute biggest model off the top of a leaderboard, yeah, that is a massive trap. It literally just leads to bloated infrastructure, completely blown budgets, and enough deployment headaches to keep your engineering team awake for a week. So today, our goal is to move entirely past that. We're going to establish a really disciplined, rigorous methodology so you can actually survey, select, and deploy the exact right open weight models for your specific workloads. Okay, let's dive into this. Here is our structured roadmap for surviving the open weight landscape. First, the variant ladder. Second, Qwen versus DeepSeek. Third, reading the fine print. Fourth, navigating Hugging Face. And finally, number 5, the 3-pass quick test.
Before we get into the weeds, I want you to burn this core mantra right into your brain. Picking the right open weight model is a survey then quick test workflow. And never skip the license read, because that is where most production fatal mistakes hide. Seriously, if there is literally one single thing you take away from this entire explainer, let it be this. You have to survey the variants, you have to test them ruthlessly against your own data, and you absolutely must read the fine print before committing a dime to infrastructure.
Right, let's get into Section 1, the variant ladder. First off, we need to dismantle a massive mental roadblock. Too many builders think of an open weight model as a single entity. They'll say, oh, I'm just using Qwen. But actually, scratch that. You're not just picking one model. You're navigating a massive family tree, what we call a variant ladder. It's basically a multidimensional spectrum that varies across 4 distinct axes. First is size. This goes from tiny 1 billion parameter edge models all the way up to those 400 billion parameter multi-GPU monsters. Second is mode, meaning is it instruction tuned for general chat or is it reasoning tuned for a visible chain of thought? Third is specialization, so things like variants post-trained specifically for coding or vision. And fourth is format, which dictates how the weights are actually packaged up for different hardware. When you multiply all those axes together, a single model family can easily spawn well over 100 official repositories.
So what does this all mean for you? Well, it means you have to find the sweet spot. And that means starting right in the middle of the ladder, definitely not at the top. The biggest mistake you can make is defaulting to a massive frontier model. They demand serious infrastructure, and honestly, they're usually complete overkill for standard, everyday tasks. Instead, target the mid-range. I'm talking about those incredible single GPU workhorses in the 20 to 35 billion parameter range. They almost always deliver near frontier quality, but at a fraction of the cost.
Moving right along to Section 2, Qwen versus DeepSeek. If you are building right now in 2026, these are, without a doubt, the 2 most consequential model ecosystems you're going to be choosing between. In one corner, you've got Alibaba's Qwen family, and in the other, you have the wildly compute-efficient DeepSeek family. Now, they operate a bit differently. Qwen is all about massive breadth. They offer the absolute widest edge-to-frontier coverage out there, and they completely rule the roost when it comes to multilingual tasks, especially with non-Latin scripts. DeepSeek, on the other hand, is structured a bit differently. They totally dominate in English and Chinese reasoning, but their true superpower? Offering the absolute cheapest first-party API access to frontier-class models anywhere on the market.
Now, what's really interesting here is looking at Qwen's specific deliverables. The breadth is just unmatched. You've got small edge models starting at under 1 billion parameters. You have specialized coder and vision language lines, but pay close attention to that mid-tier sweet spot. The Qwen 3.6 27 billion dense model, that is essentially your default production workhorse right there. It fits beautifully on standard hardware, and it can handle almost anything you throw at it. Plus, like we mentioned, if your workload touches Arabic or Asian scripts, Qwen is consistently going to be your strongest open weight option.
Flipping over to DeepSeek, you can see their strategy is really tightly centered around high-efficiency reasoning. They are the absolute go-to for complex math and raw factual accuracy. Their v3.2 and v4 models are incredible, but self-hosting those requires some massive multi-GPU setups, which is exactly why their ultra-cheap API is so incredibly popular. But you've got to take note of that consumer hardware deliverable. DeepSeek actually distilled their massive R1 reasoning model down into smaller formats, like the R1 Distill Qwen 32B. That specific model is a total powerhouse. It lets you run frontier-level chain-of-thought reasoning right on a single consumer GPU. No way we could do that as easily a couple years ago.
All right, Section 3, reading the fine print.
I know, nobody actually likes reading licenses, except maybe your legal team, but you have to understand, this is the operational reality of open weights. Skipping this boring step is literally the #1 reason builders get forced into a total painful re-architecture months after they launch. Let's walk through this meticulously, because the phrase open weight absolutely does not automatically mean unrestricted commercial use. At the top, Apache 2.0 and standard MIT, those are the gold standard. They're broadly unrestricted, you just need to provide attribution. But you have to watch out for a modified MIT. Sometimes the lab will use MIT as a base, but then sneak in a revenue cap. Tricky, right? Then there's the Llama Community License. That one limits you if you hit 700 million monthly active users, and it also heavily restricts training derivative models. And finally, if you ever see a research-only license, which pops up on some experimental Quinn variants, stop immediately. Those are strictly not for production use. Just take the 5 minutes and read the actual text file every single time.
Moving to Section 4, Navigating Hugging Face.
Okay, so once your license is completely cleared, you're going to head over to Hugging Face, the de facto open weight catalog. It can be super overwhelming at first glance, and honestly, an astonishing number of the models uploaded there end up as complete abandonware. It's like a graveyard. So you want to use these trust signals to triage a model instantly. Does it have an official organization badge, or was it just uploaded by some random user? Are the download counts well over 100,000? Has the model card actually been updated recently? And here is a massive red flag to watch out for. If you click over to the Community Discussion tab on an older model and it's a total ghost town, no bug reports, no chatter, run the other way. That simply means nobody is actually using it in a real production environment.
So, let's say the model passes the trust test. Awesome. Now you have to download the actual files. So the crucial point is that you have to match the downloaded format to your specific inference stack. If you're just running a Llama locally on your laptop, you're going to need the GGUF format. If you're building out a full precision production server with something like VVLM, you're going to want .safe tensors. If you happen to be on a MacBook with Apple Silicon, look for MLX. The trap here is assuming every model comes in every format. They don't. You really have to plan around what your specific stack actually supports.
And hey, while we're on the topic of formats, let me give you a really sharp, tactical heuristic for quantization. If you're self-hosting on standard consumer hardware, the absolute sweet spot is a format labeled Q4_K_M. It's a 4-bit quantization that miraculously shrinks the file size down by about 75% compared to the raw weights, and it still maintains completely acceptable quality for a local setup. It's pretty much the ultimate hack for getting seriously powerful models to fit onto a standard GPU.
And finally, Section 5. The 3-pass quick test.
Let's move to the climax of the explainer and see how this all builds together. How do you actually know a model works before you commit serious infrastructure to it? Well, you use this foolproof, rhythmic workflow. Step 1 is just a fast, 5-minute check using a Hugging Face Spaces demo right in your browser. Just drop your absolute hardest prompt in there. If it fails, drop the model instantly. No second chances. Step 2, you spend 15 to 30 minutes doing a local quick test, maybe via a Llama or just a really cheap API. Throw 10 highly realistic tasks at it and measure the latency and how well it adheres to your required formats. Finally, Step 3. This is the 1 to 3 hour production realistic eval for your finalist. You run a structured 20 to 50 example test set that actually mirrors your real traffic. This whole 3-pass methodology, it's not just a polite suggestion, it is non-negotiable risk management.
And just to really drive home why we do all this, use public leaderboards as candidate filters, never as decision makers. A high score on a public benchmark leaderboard really only proves that a model's worth testing. It tells you absolutely zero about how that model is going to handle your specific edge cases, your unique prompt formatting, or your strict latency needs. Only that local quick test is going to prove if it actually works for you. So, let's quickly recap these cautionary guardrails we've covered today. You want to avoid these 4 builder mistakes at all costs. 1. Defaulting to the biggest model instead of finding that mid-tier sweet spot. 2. Skimming the license text and totally setting yourself up for a legal disaster down the road. 3. Blindly trusting unverified community fine-tunes instead of sticking to official, verified repos. And 4. Skipping the quick test and just committing expensive infrastructure on day 1. If you can avoid these 4 traps, you are for sure already ahead of 90% of the builders out there.
I want to leave you with a bit of a provocative thought to wrap up our explainer today. Think about your current setup. Are your current infrastructure commitments built on rigorous testing, or are they just built on leaderboard hype? I highly challenge you to go audit your current deployments right now. Apply this playbook to your very next sprint. Read that fine print, run the 3-pass test, and just watch how much more efficient your entire AI building process becomes. Thanks so much for learning with me today, and I'll catch you on the next explainer.